Before I jump into discussion about DFM, let me tell you a little bit about Alcon. At Alcon, we develop innovative products to help people see brilliantly. We are the largest eye care device company in the world. We work in 70 countries and serve patients in more than 140 countries. Our leadership is driven by cutting edge innovation and breakthrough technology, transforming the way we treat eye diseases and eye conditions. We have the widest array of eye care offerings in the industry, with products organized into two businesses: surgical and vision care. Driving innovation is the key to our business, and we have a history of launching new products to market for the first time, driven by strong R&D. So when we talk about strong R&D, it also means keeping up with our own innovation. As a company, we share the same challenges for developing products as the rest of the industries, such as driving innovation to ensure product differentiation, contending with today's product complexities, meeting milestones, onboarding of new engineers, or just keeping up with the ever-changing regulatory landscape. To be at the cutting edge of product development, you need to have the right tools, people, and processes. As you can see on the left-hand side of the screen is a typical device we design. This product is made up of very precise, intricate parts manufactured with different processes along with new innovative technologies, all packed into a sleek Alcon recognizable form that emanates performance, simplicity, quality, and innovation. Since it's all about the eye, which is the most complex sensory organ, it means a more complex product design. If you look at the graph on the top right-hand side, which depicts as the complexity increases, the time and cost required to find DFM issues manually go up, in turn making it more expensive and longer to fabricate. But what if we can detect these issues while we design? This could drastically reduce this time and cost. So why aren't we doing it? Two reasons. Due to product complexities and concern with developing, prototyping, and testing to meet aggressive development milestones, the reality is there is no time to manually check for issues. And issues aren't discovered until we go into prototype or release to manufacturing. Another reason is managing the learnings and capturing of best practices is difficult. Most of the time, tacit knowledge remains with experts, and it's difficult to disseminate this knowledge across the organization. Also, while onboarding people from other industries, keeping them abreast with industry specific knowledge related to DFM is difficult, as it's nearly impossible to just train people and expect them to remember all those guidelines. And not everyone is an expert on all manufacturing processes. But as Nambi points out, traditional DFM approach has its own set of challenges. Manual reviews are very time consuming. There's a lack of knowledge and best practices available, and often difficult to locate these company DFM guidelines if they even exist. But what would it mean to have a design advisor recommend fixes based on your company's guidelines while you design? But let's first answer the question, why is DFM critical and why do we even care? Well, what about cost? Reducing cost without reducing performance. For example, minimizing part count, standardizing parts and materials, designing parts for loose tolerances, creating modular assemblies, streamline the number of operations in the manufacturing process. As you know, cost of engineering change is exorbitant during production, which may lead to rework, which may lead to delays. And as you know, delayed product launches have a direct impact on revenue and bottom line, including loss of market share. And knowing supplier capability and ease of manufacturing ensures good part quality that is easy to manufacture at a competitive price. Tolerances impact cost for manufacturing, and DFM highlights the risk of using such impossible to achieve tolerances for the manufacturing process. What about safety and efficacy? We must consider selecting materials for cleaning agents, fire retardants, and even water ingress. So, as you can see in the graph to the right, the time to incorporate these DFM measures manually are significantly higher as time goes on. But if we can automate this check process while we are designing, we could drastically reduce time and cost while increasing quality and getting it right the very first time. So how can we automate the DFM Check Pro process with our Creo platform? The answer is DFMPro, an add-on Creo application for manufacturing. So let's go see how this is done. The images on the top right-hand side depict a typical DFM guideline, and as you can see, it has many parameters that need to be checked before the design of even a rib can be added to a plastic part. Imagine trying to check on hundreds of parts and applying these guidelines manually. Also, as you can see, we use Creo as our design platform. It allows us to visualize the final product before steel is even cut. Allows us to create virtual parts, assemblies that make up the subsystem within our product, communicates design requirements to cross-functional design teams that all can see, and provide the capabilities and design tools to support all cross-functional design teams. DFMPro is an add-on that is directly integrated inside PTC Creo Parametric, adding manufacturability to our design platform. And with just a few clicks of a button, when we are designing, activates the design advisor. It's also linked to Windchill for DFM traceability. It also helps stage models for more expensive analysis like mold flow simulation, or even help start conversations with your vendors at the beginning of your project. Now, let me show you how we use it with an example. So open a part in Creo. Here's a plastic part, and in Design Advisor is activated to provide recommendations while you model. Just input the parameters and go. We have an option to analyze a part after modeling is complete, where we select the company guideline for this material, fabrication process, and click OK. Design Advisor will now select the pull direction, and all we need to do is input the material wall thickness desired and click OK. DFM Pro is now comparing the part against each company's DFM guidelines for plastics, as you can see here. What is nice is now company guidelines are available for all design engineers, regardless of location, and now company guidelines can be updated in real time. This is the DFM Pro interface, organized rules by criticality and shows recommendations as well as the rules that pass. This part is showing no undercuts and no thin wall conditions. Here, you can see the recommendation to add radius at the base of the boss, and by selecting the instance, Design Advisor is highlighting the area of concern on the Creo model and allowing you to comment on the issues to fix for later review with the design engineer to go and add the recommended fillet to the model, which in this case is 16 thousandths. DFM Pro also has a help menu that directs you to the content to give you further explanation on this specific rule and examples. Here are a few other rules like minimum tip at the boss with examples, or minimum draft angle with an explanation why draft is important and the recommended parameters for core, cavity, and side pull classifications. Or wall thickness, where two walls are too close, resulting in thin wall conditions that can affect the quality of the part and reduce the life of the tool. There's even a section for recommended tolerances for ease of manufacturing. Tolerances that are too tight lead to higher costs and lower productivity. Here are a few examples of how DFM Pro identifies mold dimensions from your CAD model. Now let's take another example, like wall thickness. Here it is, showing us that the base on the nominal wall, the recommended minimum wall for the plastic part is 58 thousandths, and the Design Advisor is flagging the area on the Creo model that is not meeting the guideline. I can also go to the scatter option and select multiple areas for analysis, and the Design Advisor highlights all these areas in Creo, which now allows us to add comments for the same issues all at once, saving us time. And now that we are done analyzing the results, we can go and create a report that will include all the recommendations and all the comments that have been inputted. Select the reports and click OK. Here is the Excel report with the company logo and list of rules analyzed. Let's pick one of these guidelines on this report, and we can see the recommendations for the guidelines, the actual values versus the recommended values, the comments we inputted during the analysis, including the associated image for these comments. We even have a section where we can provide action items, status, and additional team comments. The second report is a quick PDF report highlighting part being analyzed, when it was created, who created it, guidelines being used, fabrication process, results summary, number recommendation and its importance, and a summary of each general guideline with part images. That is DFM Pro in a nutshell. Imagine all the time savings identified. A design advisor that identifies and recommends advice based on your guidelines that you can act on. A centralized guidelines of the latest company standards deployed company-wide. Tools for commenting, on-demand help, and 3D reports that organizes the recommendations, comments on an Excel report that can be used in a design review with no more time-consuming manual creation of reports. Simply doing more with less. In summary, having a platform like Creo, allowing stakeholders and teams to visualize the end product, communicating the design requirements, providing the tools for the design teams, coupled with Windchill for design traceability in one working environment, gives us a winning solution for designing faster with design traceability. Creo as a platform connecting to our manufacturing solution, DFM Pro, we now have a winning solution for reducing costly design changes and reducing and possibly eliminating rework downstream, ensuring projects stay at the fast pace while reducing the worries of having downstream issues going into production. I'd like to thank everybody for allowing me to present to you today. It was my pleasure, and I hope that I was able to show you how Creo and DFM Pro can save you time and money and do more with less.